This will be a short video explaining how to name ionic compounds. A couple of tips to keep in mind. We always name the positive ion first. Elements that form positive monatomic ions will take the same name for the ion as the element had. If an element forms more than one possible ion, we use a Roman numeral in parentheses after the name in order to specify the ion. Negative ions are named second. Elements that form negative monatomic ions change their names to end in IDE. Roman numerals are not used with negative ions. Polyatomic ions have special names that are useful to have memorized. Let's look at a couple of examples. KCl. When we look at that, we should hopefully recognize that that is made of potassium and chlorine. But then remember, the negative ion, the second ion, chlorine, changes its name to end in IDE, so we have chloride. So this compound is just potassium chloride. This one, the formula looks a little bit more complicated because we have these numbers. But if you recognize your elements, you see we still have just aluminum and sulfur. It says there's 2 aluminum and 3 sulfur. And if we consider the charges of the ions, it makes sense. But when we name it, we just name it aluminum. Sulfur becomes sulfide. And we have our compound aluminum sulfide. Fe2O3. You can see that we have iron and we have oxygen. Well, oxygen is going to change its name to become an oxide. The iron is a little tricky because there's both iron 2 and iron 3, and we have to determine which one it is. So, here's what we do. Look at our formula. We're trying to figure out the iron. Start out with the oxygen. It says there are 3 oxides, and I know that each oxide has a charge of -2. On this side, there's 2 irons that are matching up. So if I have 2 irons, remember, these 2 irons together have to have the same charge as these 3 oxides, equal in charge but opposite. So these 3 oxides add up to a -6. These 2 have to add up to a +6. That tells me that my ions have to be 3+. So it is not iron 2, it is iron 3 oxide. Cu, NO3 in parentheses, 2. Now there's 3 elements here. In our compounds, we're just doing ionic compounds, so there's a positive ion and a negative ion. If I have 3 elements, I know there's a polyatomic ion somewhere. And because this one's in parentheses, it should hopefully be pretty easy to pick out that that is a nitrate ion, NO3. When we start out with copper, we again have this problem, is it copper 1 or copper 2? So compare the charges. Nitrates each have a -1. And in this formula, it says there are 2 nitrate ions. There's only 1 copper ion, so for the charges to be balanced, this must be a copper 2. So our compound is copper 2 nitrate. Another example, MgSO4. This time there's no parentheses to give us a clue, but we look at it, there's got to be 2 ions here. There must be a polyatomic ion. There are very few positive polyatomic ions. And so when I look, I see Mg. Mg is a metal, it's magnesium. I'm going to go with that. There's lots of negative polyatomic ions. SO4 happens to be the group called sulfate. And so this compound is just magnesium sulfate. Another element, another compound, NH4Cl. We have 3 elements. There must be a polyatomic ion, and it turns out this NH4, that is the one positive polyatomic ion that's common. There are very few positive polyatomic ions, but this is a common one, and it is called ammonium. Look at the second one. We see chlorine, but chlorine changes its name to chloride, and we have ammonium chloride. There's a few examples. Thanks for watching. Good luck.